Namaskar everyone. Indian Master Ji welcomes you to this YouTube channel. In the last video, we saw how normal distribution can be used as an approximation to Poisson distribution. Today, we are going to take an example on the same. If you haven't seen the last video, I recommend please watch that video first and then come to this video. I will put the link of the video in the I button as well as in the description box. But before we start today, a small request. After watching this video, if you find that the video is useful, then please like the video. Help your friends and other students who also are in need of such useful content by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on this channel. So today's question which we have taken is from paper October-November 2021. Variant 61 and the question number 2. Let's read out the question. The number of enquiries received per day at a customer service desk has a Poisson distribution with a mean of 45.2. If more than 60 enquiries are received in a day, the customer service desk cannot deal with them all. So that means if it is greater than 60, the number of enquiries are greater than 60, then the customer service desk cannot deal with all of them. Okay, they are saying use a suitable approximating distribution to find the probability that on a randomly chosen day the customer service desk cannot deal with enquiries that are received, and they are saying use a suitable approximating distribution. So first of all, let's see whether an approximation is required here or not. So let's write down the Poisson distribution. First of all, let's use a variable. Can we say let y be the number of enquiries received per day? Be the number of enquiries received per day. Okay, if this is the case, then they have given us that y follows Poisson distribution with the average number of occurrences or mean number of occurrences as 45.2. That means lambda here is 45.2. So what we had studied in the last video, we studied that if lambda is greater than 15 for a Poisson distribution, then we can approximate the same Poisson distribution with the help of a normal distribution. Okay, so here we can say since lambda is greater than 15, so therefore y following a Poisson distribution can be approximated by a normal distribution. Can be approximated by y following normal distribution. And what will be the parameters? The mean and the variance will be same as equal to lambda of the Poisson distribution, correct? So this is 45.2, the mean is also 45.2 and the variance is also 45.2. I can say where mu is 45.2 and sigma square is also 45.2. Till here there is no problem. Okay, now they are saying if more than 60 enquiries are received in a day, the customer service desk cannot deal with all the enquiries, and they are telling us to find out this particular probability. So they are telling us to find out probability of y being greater than 60. Correct? But here y, this which we are taking, is for the Poisson distribution. But we are trying to approximate the Poisson distribution using the normal distribution. So we will have to apply the continuity correction. That is adding or subtracting 0.5. So how we can do that? Let's try to see. Suppose if I draw the probability pillar for y is equal to 60, okay, then I can extend this particular pillar 0.5 to the right and 0.5 to the left. Correct? Because we are trying to approximate this Poisson distribution with the help of the normal distribution, and we have to take y ka value which is greater than 60. That means 60 should not be included and we have to move to the right. Okay. So in normal distribution, the y ka value will become 60.5. So I can say this probability of y greater than 60 for the Poisson distribution gets transforms to, okay, probability of y greater than 60.5 in normal distribution. Correct? Let's try to show this on the diagram. Suppose if I bring a normal distribution curve here. So on the normal distribution curve, here I can say y is following normal distribution with the mean 45.2 and the variance is also 45.2. Correct? The mean here is 45.2 and they are saying I have to find probability of y greater than 60.5. So this is, we are plotting the distribution curve for y. So this 60.5 will be a value somewhere to the right of 45.2. Correct? So this is 60.5 and they are telling us to find out this probability here. This area they are telling us to find out. Correct? So how we can find out this particular area? Because we have got a normal distribution term here, if we try to standardize using the normal distribution, okay, what we get? We can say this is probability of z greater than 60.5 minus 45.2 divided by square root of sigma square, that is square root of 45.2. Correct? When we standardize a given normal distribution with a standard normal distribution, then this z ka value is what? This z ka value we have studied in stats 1. It is equal to y, that is this variable, whatever the value it is taking, minus mu upon square root of variance. Correct? So that's what we have written it here. So what will be this particular value? Let's try to find out. I can say this is probability of z greater than, if we use a calculator and try to find out this particular value, 60.5 minus 45.2 upon square root of 45.2. So what value we get? We get this as 2.2757 ... But if we have to use the probability, this one normal distribution table, I need to have my z value correct up to 3 decimal places. So can I say that I have to find out probability of z greater than 2.276? Correct? So that means for this 60.5, which y is taking the value, the z will be taking a value 2.276. Correct? So this is z here. The mean value will be 0 in that case, and the same curve I can represent that z follows a normal distribution 0, 1, where the mean is 0 and the variance is 1. So they are telling us to find out this particular probability, but we can't use the normal distribution table for this one. But we also know, let me bring this down little bit. We also know that this same value can be represented like this. Let me just minimize this one. Okay, let me minimize this. Let me remove all these values here. So the same thing, can I say, is equal to 1 minus this particular section, this area. The Z value remains the same. Okay, what is the Z value here? The Z value is 2.276, correct? So when they are saying us to find out probability of Z greater than 2.276, so that means they are telling us to find out 1 minus probability of Z less than 2.276, or this is 1 minus pi of 2.276, correct? Let's try to find out this phi of 2.276 with the normal distribution table. So this is the normal distribution table. Okay, we can find out only the area to the left. So they are saying find out the probability of 2.276. So 2.27 for 7 the value is 0.9884 and 76. Another value for 6 is 2. So we are supposed to add this to 0.9884. Correct? So this will be equal to what? 1 minus 0.9886. If we solve this particular thing, what value we get? We get this as 0.0114. Okay, this answer is in 3SF. Okay, so hope you have understood this particular question, how we can approximate a Poisson distribution using the normal distribution. That's it for this particular video. Hope you have enjoyed the video. If the video was useful, then please like the video. Help your friends and other students who also are in need of such useful content by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on the channel. Comment what was good and what can be improved. And finally, till we meet in the next video, stay healthy, stay blissful. Radhe Radhe.